Hello, we're beginning Unit 6. This gets tough after a while. This intro is pretty easy. Once you evaluate the square root of 36, now put a little 2 up there because that's a type of that's the radical's degree, a square root. If it doesn't have a degree, it's a 2. So the square root of 36, so basically you're saying what times what equals 36, okay? Well, is it 1? No. 2 times 2? No. 3 times 3? No. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So you're going to write 6 down. Now, make these negatives. Is negative 6 times negative 6 also 36? It is. So you put a plus negative in front of it. Could be positive or negative. Now the next problem, the cubed root of 8. This is called a radical. Okay, radical over 8 with a little 3 out there. It's not an exponent. When it's up to the top, exponent would be right here, positioned right here. That's a radical degree 3. So cubed root is asking what times what times what equals 8. So is it 1 times 1 times 1? No. How about 2 times 2 times 2? I think so. So you put 2 down. Now make the 2's negatives. Now would negative 2 times negative 2 times negative 2 be 8? Nope, that's negative 8. So we can't put the negative, just the positive. Remember, it has to be 8. Okay, the 81 in a radical, and there's a 4 out there, so that's called the fourth root of 81. So it means what times what times what times what equals 81. So is it 1? I don't think so. How about 2? Nope. How about 3? Bingo. So we know 3, positive 3, so put 3's in there. Now make them negative and see if that still equals positive 81. Bingo. Yep. So it could be positive or negative 3. Okay, the cubed root of 64. A cubed root is a radical with a degree of 3. So what times what times what equals 64? Is it 1? No, not a chance. It's not 2. We already know that that was 8. How about 3? Nope. How about 4? Bingo. So 4, 4, 4. Now make the 4's negative and see if that multiplies to positive 64. I don't think it does. It's negative 64, so only 4. Now you're like, how come on some of them they're positive and negative, but on some of them they're just a positive? Well, if it's an even root, okay, if the radical's of an even degree, it's going to be the positive and the negative. If it's of an odd degree, like 3 is an odd number, it's going to be a positive. Okay, the fifth root of 1024. Okay, so I don't think it's 1. We can get past that. Nope. Not 2. Not 3. Not, whoops, sorry, my bad. So it's not 3. Bingo, 4. Now since it's odd, it's just going to be positive, because if we made all those 4's negatives, it would multiply to negative 1024. Okay, the cubed root of 125. So what times what times what equals 125? I don't think it's 1. 2 times 2 times 2, no. 3 times 3 times 3 is 27. 4 times 4 times 4, nope. 5 times 5 times 5, bingo. So it's 5. If we made all the 5's negative, that would be negative 125 because there's an odd amount, okay? So 5. Okay, the cubed root of 27. So what times what times what equals 27? I don't think it's 1. Don't think it's 2. What about 3? Yep, 27. So it would be 3. If you made all the three factors negative, it would be negative 27, so it would just be positive 3. And the last one, the fourth root of 625. I don't think that's 1. Okay. I'm pretty sure it's not 2. You gotta have number literacy, or you can use a calculator, I guess, for some of you guys. Okay. Aha, 5. So I put 5 in the slots. Now make your 5s negatives. Now there's an even amount, so I'm guessing that's also going to be positive 625, so we need to be putting a positive negative in front of it, okay?